Introduction to area. Remember that perimeter is the outside of a shape, but area is the inside of a shape. So when we calculated perimeter earlier in our course, we just added up the dimensions around the outside of a shape. When we're looking at area, it's how much is filled in the inside of a shape. And area is always measured in square units. So when we're writing our final unit, our final answer, we have to make sure those units are squared. So it could be centimeters squared, meters squared, feet squared, and so on. We're going to use a formula sheet, and this is a formula sheet that you would have gotten if we were to write our EQAO assessment. This is a formula sheet that you're going to use throughout the rest of the course. So we're going to use it for our area, we're going to use it for volume as well. We're going to take a look at how we can use this formula sheet to find the areas of simple shapes. Now, you may remember some of this from elementary school, but if not, no worries. So we're going to use the formula sheet to find the area of the following shapes. The first shape is a rectangle. We know it's a rectangle because it has 90-degree angles in the corners, and one side is larger than the other side. So when I'm looking at my formula sheet, my area for rectangle is length times width. So when there's no operation, there's no sign in the middle of two letters, that means multiplication. So when I'm calculating my area, I need to figure out which one is going to be my length and which one is going to be my width. It doesn't matter which one is which as long as you specify. So I'm going to use 5 as my length, so that's 5. And I'm going to multiply it by 2. So I can show the multiplication using a times sign in the middle, or I could have written it in brackets, and I'll show you what that looks like in the next example. So my area for my rectangle will be 10, because 5 times 2 is 10, and I look here at my units is meters, so it'll be meters squared. Let's try that again. So meters squared. There we go. Okay. So this would be the end of my question. So I've calculated the area. So how much of this shape can I fill in? It'll be 10 meters squared. Looking at the next example, this is a square. I know it's a square because all of my sides are the same measurement as represented by these lines that go through our sides. So the area of a square, we can use the same formula for a rectangle if we want to, or you might see the area of squared as a square as s squared, where s represents the length of a side. Remember that s squared is the same as 3 times 3 in this case, or s times s. So my 3 is my side length, so I have 3 squared, which is the same as 3 times 3. So another way to write multiplication is by taking my number and putting my second number in a bracket. So 3 times 3 is equal to 9, and my units this time is kilometers, but because it's area, I have to square it. So I have to show the little 2 as my superscript. Excellent. Now the next example looks at a parallelogram. It would be helpful if I spell that correctly for you. There we go. So parallelogram. And the area for a parallelogram, if we refer to our formula sheet, is base times height, where base is the bottom of my shape and height is my vertical height. Okay, so we don't need to use these slanted lengths in for area. So a parallelogram, my top of my shape is the same as the bottom of my shape. So this bottom length is 35 centimeters as well. And my vertical height is 12. So the area of my shape is 35 times 12. And you are more than welcome to use a calculator to do these calculations. I don't expect you to do some of these larger calculations in your head. So using a calculator, if I take 35 times 12, I end up with an answer of 420. My units are centimeters, and because it's area, I square it. The next shape I have is a trapezoid. All right, I'm going to get rid of all of that. Try that again. All right. So we have a trapezoid. If I refer to my formula sheet, the area of a trapezoid is A plus B times H divided by 2. That's probably the easier of the formulas that is represented on the formula sheet for you to use. A is the top of my shape, B is the bottom of my shape, and H is that vertical height. So when I substitute in my values, I have 9 plus 15 times my height, which is 8, divided by 2. It's very important that you follow BEDMAS when you are doing the area of a trapezoid. So first we want to do what's inside of our bracket. So 9 plus 15 is 24. So I have 24 times 8 divided by 2. I'm going to simplify my numerator first. So I'm going to take 24, I'm going to times it by 8. That gives me 192. I'm going to divide that by 2 for my last step. So 192 divided by 2 is 96. My units are meters, and because it's area, I need to square that. My next shape is a triangle. It doesn't matter what type of triangle we have, whether we have a right angle triangle or a scalene triangle like the one is shown, or even an equilateral isosceles. We use the same formula for area for any type of triangle that's given. Again, it's probably easier to use this version of the formula, which is base times height divided by 2. The base is the bottom of my triangle. The height is the vertical height, so it's the height in the inside, and then I'm dividing that by 2. So when I substitute in my values, I have 10 times 6 divided by 2. Again, following BEDMAS, so I'm going to simplify what's on the numerator of my fraction first. So 10 times 6 is 60, and 60 divided by 2 gives me 30. My units are centimeters, and because it's area, I square that. So the area of this triangle is 30 centimeters squared. The next formula looks at, or the next shape, is a circle. The area of a circle is pi r squared. When we looked at perimeter of a circle, or the circumference of a circle, we used pi as 3.14. And I mentioned if you have a pi button on your calculator, you can use that as well, knowing that the pi button on your calculator will give you more decimal numbers than just 3.14. So your answer might be slightly different than the calculation that I do using 3.14, and that's okay. So in this case, the radius is 4, because this length shows half of the width of my circle. So I'm going to use 3.14 and I'm going to times it by my radius, which is squared. It's important again that you follow BADMES when you are solving for the area of a circle. So 4 squared is the same as 4 times 4, not 4 times 2. So I can multiply that out first to give me 16. And then I can multiply my 16 by my 3.14. And that gives me a value of 50.24. My units are millimeters, sorry, and my unit is squared because it's area. If you wanted to keep this to one decimal place, you can, and all you would do is you would take your, look at your number here. So the number beside my 2 is a 4, and that's less than 5, so I could keep it as 50.2 millimeters squared. Okay. The next question looks at a circle. This time the circle has a diameter of 10. So if it's helpful for you to draw a picture, you can. So there's my circle, and my diameter this time is 10 centimeters. Remember that if the diameter is 10, my radius is the same as my diameter divided by 2, or in this case 10 divided by 2, which is 5. So if you're given the diameter of your circle, you have to calculate the radius first because the area of a circle uses radius. So the area of a circle is pi r squared, which in our case is 3.14 times 5 squared. You can calculate 5 squared in one step. You don't need to write it down like we did before in the other question. So if you can use your calculator to figure out 5 squared, or if you know that 5 times 5 is 25, you can write that expression right there. So then the last thing you need to do is to calculate that. So 3.14 times 25 is the same as 78.5. My units are centimeters squared. If my diameter is doubled, so let's say now I have a diameter of 20 centimeters instead of 10 centimeters. Let's see what happens to the area of my circle. So if my diameter is 20 centimeters, my radius is the diameter divided by 2, which is 20 divided by 2, which is 10 centimeters. Okay. So the area of a circle is 3.14 times the radius, which our case is 10, and 10 squared. Okay. So I have 3.14 times 100, which gives me 314 centimeters squared. So if we were looking up here at this first example, so even though I doubled my radius, if I look at the calculations for my area, those aren't doubled, okay? So that's important to think about. So if we want to think about the last question in our examples, how many times bigger is the second circular area compared to the first circular area? So we're going to do that by taking the area of our second example, which was 314 centimeters squared, and we're going to divide this by the area of our first example, which was 78.5 centimeters squared. And we're going to figure out how many times the second one is bigger than the first one. So I'm going to take my 314, as I said, I'm going to divide it by 78.5, and I get an answer of 4. So I know that my second, or therefore, the second circular area is 4 times bigger than the first one, or 4 times bigger to the first circular area.